Uh, Doctor, because actually just now I left out a bit. Can you send the link, the Google Drive link again, so I can go inside the Jambox? Because just now my laptop hang a bit.
Wait. Jamboard.
Okay. Thank you, Doctor. Wait a while. 11. Okay.
You got it already?
Yeah. I'm inside. Wait,
Oh,
I'm
okay.
sharing.
Okay.
Sharing. Jambox sharing. Can you guys see?
Yes.
Okay. Okay, so for our group, the situation would be a cup of hot coffee and it's put on inside an empty room. So this is actually our so the hot coffee is hot coffee we assume for 80 degrees Celsius, and also the empty room will be at 20 degrees Celsius. So the assumption is we assume there will be a fan beside the table inside the empty room, and then the empty room will be completely closed system, complete closed system, and also the cup is made out of metal.
Okay. Good.
Okay, so
I like your assumption.
so as
continue.
so as you can see, the cooler area here is 20 degrees Celsius, and the hotter area is for our cup is 80 degrees Celsius. Okay, so go on. So number one, forced convection. Actually, as you can see here, the fan will cause the air around the metal cup to move. So there will be a forced convection instead of natural convection. So it is actually due to the existence of the fan, the air will start moving, and thus heat exchange in between the cup to the surrounding air particles via forced convection. Okay, so I will continue.
Yeah, you explain first. Later, I ask you questions.
Okay, so number two, it will be the conduction. So actually for the metal cup, the free electron diffusion in between the metallic atoms carry the heat energy from high temperature region, which is the hot coffee, to the low temperature region, which is actually the outer layer of the cup, and it will transfer into the on the surface of the table via conduction, and also the air via convection and also radiation. But very sorry, we didn't write actually the radiation here, but from what I have understand from radiation, the heat will also will also transfer into the surrounding air via radiation method lah.
Okay.
Okay. So actually, that's all from our group here.
Okay. Let me ask you. See, forced convection. Okay. So after this, in topic number 2, right? When you enter into convection, when you learn about forced convection, right? So you need to know. Okay. Liang Hong, can you please tell us what determines the rate of how fast the heat is transferred, is lost from the hot coffee to the surrounding? Or
Okay, so the heat rate lost from the coffee, if according to the knots, will be driving force, which is the temperature difference divided by the resistance, which is if via convection would be I kind of forgot, but I think it's divided by something about the convection coefficient, but something divided by it. I forgot. Sorry.
Okay, just use your logical thinking because you will go into that detailed equation after this in chapter 2. But let's say logical thinking. Okay, now we are referring to heat transfer from the hot coffee to where? To the air,
Yes, Doctor.
right? The fan is blowing the coffee, right? So in this case, when we talk about forced convection, heat is transferred from where to where?
The heat transfer is from the hot coffee to the surrounding air.
Surrounding air.
But if the complete way will be to the metallic cup and the metallic cup to the surrounding air.
Okay, good, good. Okay, from coffee, the heat is being transferred to the cup first, right? Through what?
Through conduction.
Through.
Conduction.
Okay, very good. Then
And then
after that,
the heat from the surface of the metallic cup will transfer to the either the table and also the surrounding air through convection and also conduction. If conduction to
you are now talking about inner surface or outer surface.
outer surface.
Okay, so I want you to see when after this in chapter 2, you need to draw the circuit diagram, right? You need to know how many layers. So first, okay, I think this is a very good example. You see, now heat is being transferred. There are many layers, right? From the coffee, hot coffee, we assume the whole cup of coffee is at the same temperature, 80 degrees Celsius, right? So heat is being transferred from the hot coffee to where? To
To
the
the
cup, to the cup first, right?
yeah.
And the cup consists of 2 layers because the wall, you have inner wall and outer wall, right? You got it?
Okay. So need to be very specific about inner and outer surface lah.
This is after this lah. But I want you to understand, when you solve any heat transfer problem, you must, everything will be very detailed. Otherwise, you will make mistake. Okay, so I want to understand that now the heat is being transferred from the hot coffee to where first? To the inner surface of the cup first, right?
Yeah, Doctor. Yeah, okay.
Then from the inner surface to the outer surface of the cup through what? Through conduction,
Conduction. Yeah.
right?
Yeah.
Then from the outer surface of the cup to the moving air. Okay, to the moving air through what?
Convection.
Which type of convection?
Forced convection.
Why it is forced convection?
Because the air is moving.
Okay, good. Then can you please tell me how fast the heat can be lost from the outer wall of the cup to the moving air depends on what? Just, you don't need to refer to any notes. You just use your logical thinking. Daily life, how can you cool this cup of coffee or cool the surface, the cup surface faster? How?
With the rate of the moving air. So the
Speed
speed
of the
of the
fan, right? So meaning after this in chapter 2, you will also see when the velocity of the moving air increase, your heat transfer rate will also increase, right? Yeah. Okay, good. What else? Just now you also mentioned, what happened to the bottom of the cup?
Okay, so the bottom of the cup actually contact with the surface of the table, so the heat will also transfer to the surface of the table via conduction.
Okay, good. Okay, good. Thank you. What about radiation?
Actually, it's like it just the heat energy from the coffee just radiate into the air, didn't via any of the two methods here. I think so. I think lah.
Okay, let's now assume this room consists of 4 walls and ceiling and the floor.
Okay.
Okay. So now when we talk about radiation, there must be two reference points. Okay. So the first reference point is the outer surface of the cup.
Okay.
Then the second reference point is where?
Okay.
Where? Where?
The air, maybe? If yeah. The air or the floor or the
Possible, but we normally refer to another object lah.
okay.
You can say maybe the fan or the wall. Yes, the wall. Thank
Okay.
you, Priscilla. Yeah. So any heat transfer problem, right? Remember where are your reference points? This is very, very important because your heat circuit diagram depends on your reference point. Then when you first determine the reference point, then from after that you determine how many layer of resistances exist between the two reference points. Just now, like what happened to the cup, we refer in coffee in the cup. Now let's say we refer coffee in the cup as the first point. Second point is the outer wall, or the air outside the cup. So how many resistances? So first you have the wall of the cup. That is the layer of first layer of resistance. Then the second layer is the between the air and the outer surface of the cup. This one we can, don't worry, we will go further, we will explain in further in details when we enter into those topics. But I want you to have some idea first. Okay, this is how we should analyze heat transfer problem. Okay, last question, Liang Hong. Can you please explain in words, how does radiation take place? Now the reference points are outer surface of the cup and the wall. Can you explain in words?
So actually the heat energy lost in a form of, instead of transfer into the air particle, it lost in the form of wave, heat wave. Just like sun to the earth, it lost as a heat wave and then it transfer towards.
We don't normally call that as heat wave. Heat wave is a bad thing. Heat wave.
Is it electromagnetic radiation?
Yes. Thermal radiation.
Ah,
Actually, thermal radiation is a type of electromagnetic radiation. There are many types of electromagnetic radiation. For example, radio wave, right? Alpha radiation, gamma radiation. They are all electromagnetic. X-ray is also one type of electromagnetic radiation. So we don't normally say it's electromagnetic. We say it's thermal radiation. Okay. Yeah, Liang Hong, please continue.
Just transfer right via the thermal radiation wave towards the wall.
Mechanism, you must explain mechanism. How? Don't just say heat is being transferred to thermal radiation. No, that is not mechanism. Just now, group 4 explained already. Still remember?
So is it because the metal cup, it lost heat and then lost heat to the surrounding via the as in the form of thermal radiation?
We normally say the outer surface of the cup emits thermal radiation to the surrounding. We say like that.
Okay.
Yeah,
So,
continue.
okay, so the thermal radiation wave transfers through the rooms towards the wall, and then the wall surface will receive and absorb the radiation.
Then,
The particle, the wall particle will start will after receiving the heat energy, and then it will start vibrating.
that is another mode of heat transfer already. Okay, the correct way, let me tell you. Okay, you should explain like this. The outer surface of the cup emits thermal radiation to the surrounding. Okay, and the thermal radiation emitted by the outer surface of the cup falls on the surface of the wall. At the same time, surface of the wall also emits thermal radiation to its surrounding. And the thermal radiation emitted by the wall also falls on the surface of the outer surface of the cup. But since temperature of the outer surface of the cup is higher as compared to the temperature of the wall, so there is a net heat transfer from where to where?
From the surface of the metal cup to the wall.
Yes, this is the correct way to explain. You got it, huh?
Yeah, got it now. Thank you, Doctor.
Okay, thank you, Liang Hong. Are you a Fuchao?
Kind of.
Okay, based on your slang. Okay, sorry. Last group. I will call upon group number 15. Group number 15. Who is the presenter for group 15? Anyone from group 15? Are you here? Okay, Amir. Please.
Hello, Doctor.
Hi.
Yeah.
You can start now.
All right. So we assume the temperature of surrounder is 20 degrees Celsius and the temperature of ice is 0 degree. So
Mhm.
the mode of heat transfer we choose forced convection and conduction.
Okay.
So for the explanation, for forced convection, fluid move because of the moving fan, which is the external force.
Mm.
And then for the conduction, when there is heat transfer from the surrounding to the ice cube gain heat energy and the molecules will move faster, lastly breaks the bonds between the molecules to form liquid water.
Okay. You focus on heat transfer. You don't need to focus on phase change.
All right.
Can you please tell us how does the heat is being transferred now? Which 2 points are you referring to? Can you please tell me? Which 2 points are you which are your reference points?
From the ice
So point number
and
1, Ice is
And-
very big. Ice is very big. You need to be specific. In solving heat transfer problem, your point must be specific. Which point? Which part of the ice?
Which part of? Mm-mm.
Outer surface of the ice.
Okay.
You just say ice cube. Okay? You must be specific. It should be outer surface of the ice.
Outer surface of the ice. Okay.
Yeah, this is the first reference point. Second point,
From the fan.
from the fan.
Uh,
Are you sure from the fan?